So today we're at Rob's house, which is on the west side of Dartmoor, and we're talking about the work that we've done to install an air source heat pump and cavity wall insulation. The initial call that we had with Rob helped him understand an air source heat pump might actually be possible and actually quite feasible in a traditional property, but cavity wall insulation these days are much more feasible than it used to be, particularly with the bonded bead, a type of insulation, and that actually the investment in a whole house plan could be quite valuable for him in terms of confidence in taking the next steps to move towards an installation and understanding the feasibility of that installation.
Hi there, yeah, so my name's Rob. I live on the west side of Dartmoor, and in about April 2024, my LPG gas boiler was showing signs that it was going to break, and did break within about a month. The problems we'd had with LPG, there had been a few times where the country just didn't have any. Notably happened during the Beast from the East a few years back. The price of it's also been very volatile as well. Rather than just go straight to replacing it, I got in contact with Plymouth Energy Community. We kind of assessed what the situation was for me and what we might be able to do going forward to try and help me out, and that's where the plan came about. Kind of wanted to understand what the costs would be. The quotes that were put on that report were very accurate. I think actually the heat pump went in slightly less than what they were, thanks to fiddling around with the radiators and things like that. So yeah, we're very happy.
It was myself that put together the whole house plan. Initially a phone call with Rob following his phone call with Kate from Plymouth Energy Community. So I then visited, probably spent maybe 3 to 4 hours surveying the property, looking at room by room heat loss. So we assessed the construction and insulation of the building, measuring all the rooms, windows, etc. That gives us a heat loss figure, and we can then model improvements from there. And the idea of the report is to assess the viability of an air source heat pump and give in-depth design and recommendations to use going forward. As part of the recommended kind of measures or actions from the report, one of those was to have an air tightness test completed. That then gives a measured infiltration figure for the property. Doing an air tightness test can give us the actual air change figure, which is quite often lower than what is assumed. So in this situation, the air tightness for this property is 0.4 air changes an hour, when in fact we were modelling sort of 1 to 1.5. So it's a substantial change and substantially less infiltration and air changes than is assumed for an older building, and that is quite often the case that we find. So the end result of the air tightness test and cavity wall insulation being installed on the extension was that the heat loss dropped from 9.9 kilowatts to 7.9 kilowatts, which meant that the unit that we specified and designed dropped from an 11 to an 8.5. So saving the customer money on the install and also reducing size of any radiator changes. The slight disruption to this install, which can happen sometimes, is the pipe sizing that's required to the radiators. The flow rate, so the speed of the water flowing through the pipes, has to be considerably higher than that of a boiler, which means that the pipes need to be larger. So in this case, there were 2 radiators in the living room. So we made a decision with Rob to leave them there and see how they did. Commissioned the system, and then it was shown that the flow rate wasn't sufficient enough in one particular radiator in the living room, which is something that we thought might be the case, which meant that we needed to upsize the pipes to that radiator. So they were 15 mil currently. We needed to upsize them to 22 and then coming down into 15. So we then revisited, upsized the pipes to that particular radiator, and now we're hitting the required flow rate there. Replacing LPG for a heat pump and then gaining sort of between 300 and 400% efficiency, which is what we tend to aim for. But he said he's saving money and he's happy, he's warmer all the time, so that's a benefit. And yeah, happy with it.
Because of the heat pump and the way that the radiators now work, the house is much more even temperature. Previously, because there's different parts of the property of different ages, and it was very noticeable going from one room to another.